Yeah, hi everyone, wherever you are. I saw some participants from all around the world. So I hope you're having a good day, and thanks for sticking with the schedule and making it to the last talk. So this is a quick crash course on how to use containers on Theta and Theta GPU. And this is material that I have set up with the help of Taylor and Corey, who are going to be helping me out in responding to questions while I'm speaking, and of course after I finish. And so yeah, so let's get started. So feel free to stop me anytime if there's something egregiously wrong. But when in doubt, use the Slack channel for us. Okay, so we'll be looking at actually how to use containers on Theta and Theta GPU, and I'll tell you what containers are if you're not familiar with it. But basically, you'll see that it's really cool. It's a really cool mechanism to pick up some apps that you're developing on your laptop, and not really having to go through the pain of building on Theta or Theta GPU, which I'm sure a lot of the people in the audience have suffered countless hours with. So when I first started using containers for a few of my applications, I was really quite happy at how much time I could focus on, I could devote to focusing on the science or the result of the simulation as against actually trying to build a particular code. So and so the process that I'll walk you through today, along with some codes that are going to be available on the GitHub repository and on my repository, will help you sort of get started yourself. Okay, so what are containers? So if you've been paying attention to the concept of virtualization, you may have heard about virtual machines, and more recently you may have been hearing a lot more about containers. But virtual machines or containers are in spirit similar. They are these virtualization technologies that actually help you achieve isolation for a particular task. For example, the levels of isolation are different. So for example, on the left, if you've ever had to run Linux on a Windows machine, or if you've had to run Windows on a Mac machine. Sorry, my cat wants to. Yeah, so you would have installed virtual machines, which are basically something known as, or they are considered to be hardware level isolation. So what happens is you have a layer of abstraction called the hypervisor, which actually runs separate operating systems, and which are associated to a certain sort of component of the hardware. So for example, if you had a rack of servers, you might want to split it up amongst multiple multiple operating systems on virtual machines, and these independent OSs would not know anything about each other. So you'd mimic a multi-machine sort of setup on one rack. On the other hand, you have containers, which are giving you task level isolation. And you can see the schematics changes slightly. But instead of actually setting up multiple operating systems, what you make is like the name says, a container, or that actually has all the relevant libraries that you need to run a particular application, and they are all run on the same host OS, right? So it can have images of different operating systems, but at the same time, you will only get task level isolation and not hardware level isolation. So that's the high level idea. So you can, for example, access the same file system when you're running multiple containers on a particular machine. If the most widely used container platform is Docker, which has been around since the early 2010s. If anybody has been looking at containers previously on non-LCF machines, you've probably been looking at Docker, right? Unfortunately, due to security issues, Docker is not supported on ALCF systems. And so we use Singularity, which was developed for this particular reason, as our container technology. Unfortunately, installing Singularity and creating an image on Singularity that you can then sort of pull to Theta and run your app with is a little more off nominal compared to using Docker. But fortunately, Docker and Singularity have excellent interoperability. So what we'll be looking at today is you, the audience or the viewer, will be using Docker on, for example, your laptop, and then you'll be using Singularity on either Theta or GPU or Theta GPU, and that you'll see perfectly blends ease of use as well as bypassing the security issue on Theta. Okay. So how do you use Docker? Well, there's two major ways to use Docker. So the first one, which is quite intuitive, is to actually build an image on your own machine and just use it like you were using an operating system. So you for example, you'll download from the official Ubuntu repository. I'm a Linux man myself, so you'll download Ubuntu, and then you will install your app. You'll install all the required libraries into that image. And then what you will do is you will push that image to dockerhub.com, which is basically GitHub for Docker images. And then you can pull from Docker Hub to any sort of different geographical location. Or for example, you can even pull onto ALCF using Singularity. I'll get to that in a while. The other way to use it, and what we'll be following for this talk, is not actually installing Docker on your laptop. So the first way that I just talked to you about requires you to install Docker on your laptop, which is not very difficult. It's a 10 to 15 minute thing. And so if someone does want to do it that way, feel free to reach out to us. But if you, for example, for whatever reason, do not want to install Docker on your machine because you don't have sudo access or whatever, there is this nice property called auto build. I called it auto build. I don't think there's a specific term for it. But what that does is you can link your GitHub repository. I'm assuming people will have knowledge of what GitHub is. And you can then create a recipe or a Docker file, which actually builds for you on Docker Hub. So Docker Hub can actually build your image on the cloud, and you can use that to so you won't have to install Docker on your laptop to do this. Okay. And so just to make sure people are on the same page, the Docker version we used today was 20.10.6 on my laptop. So all right, so what does a Docker file or a recipe look like, right? So it's basically a script that will have all these commands that you would run on your laptop if you were, for example, installing the required libraries and for example, copying source code into your image, for the first time. So an example Docker file could look like this. So you for example, this from command over here would basically tell Docker that you're going to download an image from a particular repository. So that's the syntax. You will see that you can also download images from, for example, my repositories or your older repositories. So that's something called bootstrapping. So you can build images that are already built on previous images. So over here, we'll take the latest release of CentOS. And what we will do within this, after that is downloaded, is we will run a bunch of commands that actually install your dev tools, your development tools. So for example, over here, I'm telling Docker to make a directory for me where I will be actually copying all my files. So, for example, if you want to build an app, you'll probably have your own source code, right, in your GitHub repository. So relative to the path of your Docker file, so I have the schematic here, you want to copy whatever is there in the source folder into your Docker image. So that's something that you install over, that you mention over here. And then following on this, the run command is basically like a, like a command that you run on your command prompt. So over here, I'm just installing, my standard building tools, my compilers, and following on from this, what I'm doing is I'm installing an MPI-CH because I want to run an MPI app, right? So, and I want to run this MPI app eventually on Theta. So we'll have to go through a few more hoops to actually get that done. But you will see that if you just go through these commands over here, what I'm doing is something that you've probably done with your eyes closed multiple times, right? So you've basically downloaded the MPI libraries from a website using wget. You have untarred it, you have configured it, and you have then installed it, right? And then you have added it to your path so that when your executable has to be built using the compiler, you can find all your libraries. Okay, so again, over here, I finally decide to copy another submission script. I'll show you what the script is in a while, but you'll need it basically to execute this executable that you created. So you've created an executable that I've called py over here, right? And we need to basically run a shell script command to execute that, and that's kind of what is done in the entry point command over here, right? Okay, so so what you need to do to actually follow on with this tutorial is to make sure that you have both GitHub and Docker accounts, and it's extremely easy to do so. So once you have that, what you can do is you can actually push your Docker file to a GitHub repository. So over here, for example, I created a new repository called Theta containers. This is a real repository. You can go and take a look at it. And over here, I have a lot of other junk, but what's important to us is that I have added a folder and then called Docker files. And within this Docker files folder, I have several Docker files, as the name suggests, but I have several independent builds that I want to run for several independent images that are under these underscore app designated folder names. Okay, and so so if you have something like this set up in your GitHub repository, again, like I said, should have this sort of structure. It should have the Docker file. It should have a folder with all the source code that goes into the image when it's being built on dockerhub.com. And then the submit.sh can also be assumed to be source code. Okay. All right. Now that is done, right? So fret not about all these things over here. I actually have a screen capture video that I created to go through this process. That's also on the the ALCF GitHub repository. So you can just double click that. That's an MP4 file that shows how you can create one of these things, right? So you go ahead and click create repository within dockerhub.com. You give it a name, you give it a 100-character description, and then you connect. This is initially going to be disconnected. You connect your GitHub repository. It will ask you to connect a specific repository, right? So in our case, our specific repository was Theta containers. It will give you a list of all the repositories that you might have. And then once you do that, it'll ask you to give your image a name, right? And it'll also ask you to point to the Docker file, okay? So over here, for example, our Docker file was in relative to the base path of the repository. It was in Docker files, MPI app, and then over here. So over here, I'm giving it a simpler example first. I'm giving it Docker files, hello world. There was a hello world example as well, Docker file. Okay. So once this goes in over here, you can hit create and build, and this is going to be slow because well, it's slow. This would be a lot faster if you did it on your laptop, but we're assuming you don't have sudo access. So when you do hit create and build, maybe you can step out for a cup of coffee. It depends on what you're doing in your Docker file. Over for the hello world application, I think it took me about 5 to 10 minutes. I had to hit refresh a couple of times. But the MPI application over here, since it's got all these since you have to actually make MPI, it can take a bit longer, right? Okay, so and you can track build activity in your Docker Hub repository and you can see that your failing builds or successful builds will show up down here. By default, builds are assumed to be automatic on commit. So for example, if I make a change to the Docker file, if I make a change only to the Docker file over here in my repository, which I've linked, it will trigger an automatic build. Okay. And so if something breaks, you'll see it right away. And so this is how you track it, right? And if it's successful, you're in luck. If not, you have to go into your build logs again. You just click on the build that was broken, right? And then you can look at a couple of different this source of information. So the build logs will tell you that so you remember I was showing you the steps that that go into your Docker file over here, right? So those basically will show up here as well. Over here, I was showing again. I was actually building from another image, so it's going to show these same steps. If anything fails, and also alongside the logs that you see as if you were building on your machine, you can also see your Docker file. So over here, I have the Docker file for the MPI app showing up over here. That's exactly what was there in the previous image. Now, something that has happened to me off and on when building with Docker Hub is failing to build when I have to copy files. Like for example, over here, you have this command in your Docker file which says copy from a certain source to the file inside, and so when this happens, and this is also something that's there in the video, by the way, this demonstration, when this build when this copy issue is present, you will see that the build has failed, and you'll get something in your logs which says that file was not found. Okay, and in that case, there is a configure automated builds link in your repository settings, which you can use, or your build settings within your repository, in which you can go in there, and it gives you a lot more information regarding for example, what the context of your build is. So what is the context over here? It's basically the location of your Docker file, and the Docker file location is the name of our Docker file. Okay, so this build context option, unfortunately, is not available when you actually start a new repository. I dug around a bit for this, but I couldn't find anything that lets me specify the context right away. But if you do get a build failure because you don't see like a file that is supposed to be copied, then you might have to go into the configure automated builds thing. If this is confusing you, like I said, go into the repository, look at the tutorial, the video captured that I did that actually demonstrates this same issue. Okay, so yeah. All right, so now that your build is successful, you will see something like this, right? And you can trigger rebuilds as well if you want. And so basically now your image is hosted on your Docker Hub repository. In this case, I call it ALCF tutorial 1. Now let's go ahead and try to pull it to Theta, for example, and then run it, right? So like I said, Docker is not supported on Theta, but Theta does have Singularity, and the version of Singularity that's on Theta right now is 3.6.4. And it's exceptionally simple to actually now take your app that has been built, auto-built on Docker Hub, and then pull it to Singularity. All you need to do is just execute this command. By the way, all the bash commands that you may need to run on Theta are highlighted, so just to stand out. So all you need to do is use this command, Singularity build, give your image a certain name. So this is up to you, and then you can actually pull it from Docker using this sort of path to your repository. So Docker, your username in Docker Hub, and the name of your repository, and also the name of the image. So you remember in our repository, there were multiple images which all corresponded to different Docker files in my GitHub repository. So you can have multiple images in one Docker Hub repository. Okay. So once you pull that, and you can shell into your image and actually see what files are there. For example, you can open your working directory, which you remember in our Docker file was mpich, and within your working directory you will see that we downloaded the tarballs from mpi ch.org using wget. You'll also see your executable. You'll also see your shell script, which over here is very simply going to go into mpich, the working directory, and then execute py. Okay. All right. So now to run this on Theta, one thing that you may be wondering now is you actually used mpich from mpich.org to build your executable, but Theta uses cray MPI, right? And so if you natively try to run your app, your MPI app using a standard submission script, you'll basically end up getting a your code will crash, so it won't work. So for to deal with that, you actually need to switch out the MPI that you Cray generally uses with a application binary independent MPI build, and so that is performed using module swap, right? And once you actually do this, you can use this MPICH ABI to work with apps which were built using a different MPICH. And using this script is also, by the way, available on the GitHub repository, my GitHub repository, as well as the one that ALCF has. So fret not if you don't see everything here. But what you need to do through this is now that you can pass your singularity image using this environment variable singularity and LD library path, the paths to the additional libraries that you need to actually use Cray MPI. Okay, and you're just doing some string concatenations over here. And once you're able to do that, you can then run your container, right? What will you run in the container? You'll basically be running the submit.sh shell script, which was mentioned in the entry point keyword over here. So whatever you put in the entry point is what gets executed when you hit singularity run. Okay, so the final command is your app run. You give it, if you've been paying attention since this morning, app run basically requires you to specify how many total ranks you're going to use, how many ranks you have per node, and then you do a singularity run. The bindings over here correspond to what file system the singularity should have access to. In case, for example, you're writing file out, the singularity image is read only, so you cannot write anything into your image, but you can write it into your file system that way. And then finally, you have a container name, which is an argument that goes into when you do your qsub from your command line. Okay, and so when you go ahead and try to run this app, so interestingly, because my Docker Hub repository is public, you can actually do a cute little hands-on starting from this slide over here and try to reproduce these results. You don't really have to go in and build your own thing, but that would obviously be what you do downstream. You would see something like this, which is basically just a hello, well, just each worker checking in and computing the pi in parallel. And so this is something that you will get. Okay, so very briefly, what we want to do next is look at something called bootstrapping. Bootstrapping basically is a way to use an image that you've built previously and is available on Docker Hub. So for example, the MPI app was already built and available on Docker Hub. All we did is we made a new working directory, we copied new source files in there, we installed some new libraries, we added a new entry point, or we updated the entry point, right? And we created a new sort of image from this, and we uploaded it to Docker Hub again. And if you, for example, run this guy now, what I was doing over here is basically just printing some hello worlds and some version information from NumPy and TensorFlow. So you could even, for example, not have to worry about using a Conda environment, for example, on Theta. if you had a container that had all the correct versions that are required for your app. Okay. All right. So very quickly, I'm going to go through Theta GPU and how to use containers on Theta GPU. So of course, the steps that I just mentioned to you are applicable for running on Theta GPU, but Theta GPU fortunately embraced containers wholeheartedly right from the start, especially for deep learning type applications. And of course, all this stuff that I'm talking to you about is also available in very well documented. And this link over here, this should not be highlighted. It's not a bash command, sorry, and this one either. So what we want to do is use the containers that are already available on Theta GPU and basically shell into them and then install any additional libraries that we want as using say virtual environments in Python, and then running our for example our Python scripts using these virtual environments, right? You can also run for example C and C++ executables using these virtual environments. You just have to download the right compilers using and then build your application using them. So for example, let's say you grab like um, an interactive node on Theta GPU, and then you can access different containers for deep learning. These are optimized for deep learning, but like I said, you can also use them for simulation. But Theta GPU generally is used for a lot of data science workloads. You can activate the singularity container using this command over here. Again, the bindings -b over here give you access to the file system. And within this container, if you want to install new packages, you just have to export some proxies to get access to the internet. And what you have to do after this is basically use a virtual environment, which you can start using these set of commands over here, within which you can then install a new package. So for example, if you want to install sklearn and it's not available on one of those containers, it might be available. This is just an example. All you got to do is you have to source your virtual environment and install this additional package. So for example, I wanted to run some simulation workloads on Theta GPU. So what I did was I actually installed CMake, which is also available through pip or even through Conda. So after installing CMake, I was able to build my executable and then run a classical simulation workload. Okay, and basically, this is just some filler material, but over here I have the script that you'll need to actually run an executable from a container using the virtual environment. So you just have to give it the name of the container that we're running. Over here was a container which had TensorFlow 2 built into it, optimized for the A100s, and a submission script. Within this submission script, you would have a set of commands that activated your specific virtual environment, and then run your Python script. You could also, for example, like I said, if you've built using a particular virtual environment, you could also specify a C++ or a Fortran executable to run on Theta GPU. Okay. All right. So this is what I have. I'm a little over time, so I'll apologize for that. If there are any questions, I'd be happy to take them. And as usual, feel free to reach out to me whenever for clarification.